My name is David Yarowski. I'm a professor in the Department of Computer Science. My office is upstairs on the third floor of this building. I'll be a member of the team on distilling knowledge from Ngrams this summer. So you'll be seeing me in the lab if you're staying on. Not quite sure why Fred is here and Hinek, but folks don't want to
never heard you, David, so I thought this would be a great opportunity.
Wonderful opportunity. Thank you, Fred. Okay, so today, this is a follow-on presentation to what Jim gave this morning in terms of Jim presented the core of information retrieval, and I'm going to select a number of topics post hoc from that core in terms of covering sort of newer techniques or applications that are considered for other topics on the web, for collaborative media, for social network analysis, and so forth. So I'll be going kind of picking and choosing from a number of topics that I cover in a course that I teach in the spring on information retrieval and web agents. So hopefully the combination of what you see from Jim's lecture this morning and mine should cover a good spectrum of the IR market. So the first topic that I'm going to try to cover is often we have not just IR on one data collection, but we have IR on many such collections. And they have different properties, and the question is how do we merge things? Another way to look at this is we have, in many cases, multiple engines that have different strengths, and we'd like to fuse them together. A good example of this is the Metacrawler architecture that was developed by Ornazioni initially in the mid-90s as a way of taking data from multiple search engines. This was even before Google, but Yahoo and InfoSeek and AltaVista, and realizing that they all had limitations independently, but could we fuse things together? And this data fusion is something that is obviously of interest to general statistical modeling, but it is particularly useful for the IR framework where, at least prior to Google, we did not have this notion of superior modeling from any one source. So the general notion here is that we have all these different systems out here. We have Lycos, AltaVista, InfoSeek, and we can replace them today with Google, but it doesn't really matter. Ultimately, there's some hope that the market will have a new burst of sort of specialization where we'll see search engines that are very good at particular genres, images or sports news or financial information or legal things, where one vendor does not solve all the world's problems. So although this is less relevant today than it was, let's say, 6-7 years ago, I believe it will become more so in the future. And the general notion here is that if we execute a search in parallel on multiple engines, or if we execute the same search on multiple collections, this works in both ways. It doesn't really matter which one you particularly are addressing at any given time. The algorithm is the same. We get back a set of responses. So a given document, color-coded blue here, might be ranked 6th in this engine or this collection, score of 0.92 here, score of, let's say, 2.0 there, and comes in first in Joe's spot. And the question is, what do we do with these things? How do we integrate them? How do we merge them? So any suggestions? How do we decide which of these things is in a fused model? Should we rank red first? It's scores first 3 times, or does blue look better for some reason? And on what principles would we make that decision? Well, it kind of depends on a number of factors. One, obviously, is a ranking of to what extent we believe that any given engine is consistent with our needs, or what any given source is consistent with our needs. Joe's bot may be very, very good at predicting my personal quirky tastes, much better than Lycos or AltaVista or Google, as the case may be. In other situations, we're more mainstream and we want to take a consensus of these views. Another possibility, of course, is that even if we give them all equal weight, or we have our own weighting scheme, we don't necessarily know how to merge a rank of number 6 with a score of 0.92, with a score of 3, with a score of 0.95. It's not all clear how these things fuse. So clearly, we need to deal with different weighting schemes, different relevance scales. Some are logarithmic, some are linear, some are in ascending order, some are in descending order, some have no ranking at all. We have different sizes of the response set. It's not at all clear when we get back 50 documents from one and 5 from another. Does this mean that one is more selective, or one has a larger catchment area, and hence they're equally selective, and we should fuse them equally? It's not at all obvious. We have different sizes of the response set, different biases of the collection. We have to worry about duplication, identification, and removal, and we also have to assess to what extent meta factors, such as the latency or bandwidth of the source is providing it to us in terms of sort of our cost, in terms of time, or sometimes there's a monetary cost involved. We have to pay for these things, and are we willing to take the recommendation of an expensive source over a free one? So in general, we'd like to learn the ranking scale, the ranking reliability, and the relevance ratio. So in general, come up with some sort of fused ranking, either on engines or on collections, that's a weighted average of some sort of function applied to the rank that's given to us by each of the source algorithms or engines. I'll skip this. And one quick comment. A lot of the meta-crawling model is economically problematic in the sense that we're letting Google and Yahoo and Microsoft do all the work for us in some ways, and then we're reselling all their energy and their access, bandwidth charges, and their storage, all the work they do to collect and provide this data by providing a wrapper. And this is obviously problematic. We don't necessarily want to be a parasite on the system, but some would argue that actually fusing results together and coming up with a unique consensus view is actually advantageous. So one alternative, of course, is we can actually charge people and then pass this money on to Google and Yahoo and Microsoft and other specialized bots. Or we could pass on their advertising. We could essentially agree to forward their advertising through. Now, this is not necessarily desirable to search engines in general. They don't necessarily like to have either of those options. They want to have brand identity established. They want to have you as sort of a locked-in client. And they're not generally happy with meta crawlers. So one of the problems, of course, is how to overcome this. Now, the response of most of the providers is simply to block any kind of query from a meta crawler site. Now, people got around this by having sort of Java-based code in your browser that looks like it's coming from you, as opposed to coming from a centralized site, but engines are carefully productive at detecting these things. So it's not at all obvious how to solve this cat and mouse game. But in general, partly because of the rise of a single sort of monopoly power, and partly because of the rise of inefficiencies in this process, as you don't get a whole lot different from Yahoo or Microsoft from Google, meta crawlers have become less popular than they used to be. But again, I expect this to sort of emerge again as we have more specialized providers in the future. Editorial comment aside, we're in a situation now where we'd like to have this sort of rank as a function of some function over the rank of a given algorithm or engine on a collection and a document. And this may need to do some sort of transformation in various ways. We'll come back to that in a moment. One model is assuming that rank is proportional to relevance. I'm sorry, forgive me, relevance is proportional to rank, where we're assuming that collection sizes are equal, and if a particular engine or source has a small return set, it simply means it's more selective. So if collection 2 or engine 2 gives us 5 as opposed to collection 1's 10, if we assume equal selectivity, we assume the first ranked in each has equal merit, the second rank has equal merit, and so forth. And we interleave them in this way, and then the collection 1 is simply returning more documents. It's being less selective, so it's second tier fall at the bottom. Another option would be to assume that these are equally selective and that relevance is proportional to rank over total return. So if we're in the top 10% of our return space, that should be equal. If we're in the top or the middle 10%, those should be equal. So in this case, a smaller response set simply means that we have a smaller collection that we're choosing from, and our bottom document should be paired with the bottom document from the first collection because we're equally selective in terms of our percentiles. So we're interleaving in different ways. Now, in general, we would like to go beyond that. We would like to learn the mapping in more productive ways because these are assuming, again, this is simply rank-based correlation, but we don't want to throw away the scores. The scores have merit, the scores have content, and we would like to use those in various ways. So we'd like to have some mechanism to learn how the scores from an algorithm or from an engine can be merged in various ways. So we have essentially their ranking and relevance judgments, their past performance, their correlation between their results and our results, and a parameter indicating the service provider, and try to learn a function that takes those parameters and computes a sort of consensus score that matches our needs. So a good way to think of this is if we have system rankings for multiple collections or multiple engines, again, the model is isomorphic between those two tasks, we get a set of scores that come out of these different things. And we can take those things and map them onto our own judgments. Now, this takes work. It's not trivial to do this. But in general, we have to assume some investment of the user to actually give feedback, saying, OK, this document, given my query, is, say, a 10. This is a 9.3 or a 100-point scale, a 93. This one is a 5, and so forth. And essentially give feedback as to how this matches the needs of an individual. So this could be a child interested in why their grandmother has a certain disease and is interested in a certain set of things, while a researcher in the field might be interested in another, while a caregiver may be interested in another. They all have different needs that are being assessed in terms of these different models. And what we'd like to do is map the scores given by a particular engine or a collection. These may be medical documents, which don't fit very well to a grandchild, while educational documents or so forth might be more appropriate. Again, assuming we can elicit either manually or automatically the feedback that's desired from these individuals, we can map the system scores onto the sort of specialized user-specific space. And the nice thing about that is this is universal. This is all different collections, all different engines, all different scales can be mapped on this sort of 0 to 100 scale or 0 to 1 scale that represents the user's success or the user's desire for that outcome on their particular need scale. And if we do this, what we tend to get is these different curves. Now, I'm actually showing only those that increase, but obviously a descending logarithmic scale or a descending linear scale would have a curve that looked like this. And all different scales, no matter how they are, can be essentially done through various regression means to sort of fit a mapping between the system scores and the ultimate user judgments. Now, obviously, an ideal system would be one that perfectly mirrored the user to begin with, that if the system gave a 0.5, the user would have given a 0.5. The system gave 0.99, the user would have given 0.99. That would mean a system that's perfectly in touch with our interests and needs and our particular biases. Those are rare. But what we are trying to do is take the consensus of multiple systems, what they score, and obviously there's a lot of variance here, but trying to map those curves to allow the score or output of one system to be mapped into user space. And then once you've done that, then we can weight these things proportional to our confidence in the outcome, to our cost factors and other such things that may allow us to do a linear combination or other kinds of weighted combinations of these systems. But we first have to get them into a common universal space, and this is how we do that. Okay, so any questions about this before we go on to 3 or 4 or 5 more topics? Yes?
Is it possible that the user ranks some results higher than the system?
Oh, of course, yes, forgive me, yes.
The whole, no?
Yeah, in fact, a good example of this would, right now this is assuming that the user is on, say, a 0 to 1 scale, while the system may be on a 0 to 100 scale. Now, if the converse was true, if the dynamic range of the system was less than that of the user, then you would have curves up here. And as I said before, we could have curves that are descending if the user goes into ascend, good is high, while the system good is low. 1 is good on a system as opposed to like in rank order. So we will see all sorts of different curves, different scales. And the nice thing about this is that if we do sort of separate regression models, depending upon whether these are linear log or rank-based or score-based, we simply get everything into one unified space that can be merged in a simple linear addition once we've mapped everything to user judgment space. Okay. So number 2. Oops, no, that's not going to work. Sorry. I just got this machine, and no, I decline your product. Thank you. Go away. And I'm getting a new disk here. Okay, so actually, before I continue on to collaborative filtering, let's first talk about sort of. Actually, I'll talk about this first. And then we'll talk a little bit about link analysis. So collaborative filtering is another way of looking at the world. And this is essentially, I believe that Jim this morning talked about relevance feedback, right? That's where it's essentially a probabilistic model where different individuals will, much like I just showed it in the fusion model, give their feedback on a given document. Now, I was showing that in the context of trying to learn the weighting and then the mapping between a given systems or collections response function and a particular user's need. We can obviously have that in terms of learning parameters, learning weights of individual words or features or terms for a given relevance equation. Now, the problem is collecting that feedback is very useful, but also very expensive. There's not a lot of incentive, in fact, for people to do that. Humans often don't have time to give these judgments. They're busy. And more importantly, once they've done this, it's wasted. It might help someone else down the road, but it's not likely to help them. Now, there's one exception to that, of course. So this is a long-standing query, like a clipping service, where you're always interested in documents about a certain need. Maybe a particular company is interested in documents about it or its product lines. Government might have long-standing needs of interest about certain kinds of priority concerns. People might be interested in particular hobbies they have. They're interested in all new technology about intermediate basket weaving, that they want to be apprised of new techniques for doing underwater weaving of things. And they will have the standing query that they want running in the background at all times. But in general, for a given query, you want to know, when was Britney Spears married? That particular query will go away, and you will not likely ask it again unless she gets divorced. And it's not worth your time to say, this one satisfies my need, this one does not, for a query that you will never ask again. Now, someone else, in contrast, may indeed offer that query and benefit from the fact that you said that item number 4 on your favorite search engine's response list is really good for my needs, and 1, 2, and 3 are not appropriate. But they will benefit, not you. And the question here is, how can we pool the collective social good that achieves when I scratch your back and you scratch mine, and overcome the in general selfishness that we would perceive if everyone only did things that directly benefited them without sort of a collective wisdom. So this collaborative filtering is trying to pool the consensus judgments of individuals to help each other and ultimately help themselves by this collaborative effort. Now, I'm not going to really spend as much time on collecting of judgments. Again, there are automatic means we can do this. We can, you can look at whether someone prints a document or whether they save it to the disk, whether they email it, whether they maybe can install eye tracker to see if they actually read this thing. If you have something installed in a browser, you can see if they scroll down give some sort of model of actual need. Many search engines today, when they serve up a list of links, they don't actually serve up a direct URL. If you click, you actually click on a sort of meta URL that's hosted at the search engine site, for example, Google, with the URL as a parameter. By going through Google, which will then sort of forward your request and actually generate the page, the search engine site has a record essentially of where you've gone and what you've clicked on given a set of pages. So they're able to get some sort of feedback about what you consider to be at least potentially relevant based on your view of things. And in some cases, they're able to timestamp when you go back to see the next page. So if you immediately return and click on the next link, that suggests that you did not find this to be terribly useful. But you can't tell if someone comes back 10, 20 minutes later, whether they really like this page and have been reading it intensively for this entire time, or whether they got a phone call or went to the bathroom. It's very hard to know these things. In contrast, if you have a browser, you actually can see motion or have some sort of meta way of capturing these things. You have a better sense of genuine interest. Now, putting aside for a second the question of how to automatically capture these things, because in some ways that would circumvent the need for collaborative filtering. If we could have sort of perfect judgments of individuals with respect to what they think, maybe have little sensors in their brain that would say, oh, I like this and don't like this, we may not have as much of a need for collaborative things. Although, of course, for a new query, for a new information need, where we don't have individual judgments, we still benefit from the wisdom of crowds, wisdom of others. We'd like to somehow incentivize people to share these things, share their judgments, share their either manually collected or automatically collected feedback on whether something is good or not, either at an absolute sense or relative to a given query. The second motivation for this work is that relevance does not equal quality. Obviously, if you issue a query on Britney Spears or Cleopatra or Egypt or Alzheimer's, you're going to get, in all situations, I mean, literally tens of millions of responses, all having that term, but all not equally beneficial. They may be relevant. They all may be about that thing. But that does not mean to say that they're all equally desirable as an outcome for your particular search need. And there are many ways that something can be about a topic and yet not desirable. There are differences in quality of presentation, detail, professionalism, and substance. There's production values. You want to see a really high quality, slick site as opposed to something that's sort of thrown together, something that has high quality facts as opposed to low. So clearly that's one problem. The other problem is that, well, I'll come back to the second problem in a second, but addressing this first one, we could, in theory, build a supervised learner that would assess quality and not topic fit. So this would be a sort of different set of feature spaces that would, in general, try to say, okay, let's assume this is relevant for the topic. Let's assume that it actually fits in terms of the match or the terms to the given user's need. How can we assess whether this particular site is a good one or this site is a good one based on meta properties in terms of abstract quality? And again, this is a subjective judgment. Some people might like incredibly complex graphics and flashing lights and all sorts of embedded flash content. And some people might like trimmed down, just the facts, ma'am, very basic, clean, sleek lines. So this is very much a personalized judgment. But in general, if we can get sort of collective feedback from individuals or their cohorts about what's a good site in terms of production value and what's a bad site, we could try to have a sort of a secondary classifier that would assess quality of the general site. Now, this could have things in terms of the reading level. Obviously, if my daughter, who's just learning to read, is looking for something, she's going to want a very different set of content than a 10-year-old would or a professional in the field would. So we might have something that assesses the complexity of the words, the number of syllables, sentence length, and so forth, to be a good fit. People, again, may have different desire for visual aids. I'm personally a very visual person. I much prefer to have images and graphs and diagrams. My wife detests them and really just wants all the words. When we read books, I look for all the pictures. She starts reading from page 1. So having some mechanism that tries to look for these meta properties and assess relevance is desirable. And again, that's one way where the machine can sort of kick in and play a role. We also can imagine, in general, the number of links, the size of the page, how often it's cited, which is sort of a not quite collaborative filtering, but it's getting there in terms of having official measures. Now, I'll speak in a moment about PageRank, but this notion of citation is obviously a measure of quality. Variety of content, some sort of awards. Again, these are less relevant today. They were more so in the size in the old days, although certainly being cited by prestige sites has effectively that same function. Some sort of hit counters, again, these are easily manipulated. Complexity of the graphics, prior quality ratings of the server in general. If I see something from the New York Times, I generally believe it's likely to be of high quality, even though I've not actually seen that particular page before, because of the prior record of high quality from that site. So these are all potential features that could go into a calculation of quality given a feature vector. And you obviously can imagine your own. But again, we're assuming the machine is working here. Now, let's say we now also want to assess the fact that independent of quality and independent of relevance, there's this different information needs that apply for different classes of individuals given the same query. So if someone has a query on Alzheimer's disease, caregivers may be interested in this space of documents, medical researchers may be interested in these set, and a sixth grader interested in what's happening to grandma might be interested in this set. And in general, there may be some overlap, but these are often disjoint spaces. And this is, again, a very crude demarcation. Different lay people over different levels of sophistication may want different kinds of things, which may overlap with medical researchers or caregiver needs. But let's assume, in general, that there's this continuum of sort of prototypical needs for individuals of different backgrounds and classes, given the exact same query. And the same thing could be true for any technical query. A query about Cleopatra will have a very different response set for a child doing a book report as opposed to an Egyptologist looking for particular needs. So one idea here is to pool the collective wisdom of many, many individuals. And weighting those collective wisdom assessments by the individual sort of closeness to the person we're trying to target. So one idea here is to do this in a Boolean way. You're either a member of this affinity group or not, and take the collective wisdom of that group. Or we can do this in a pairwise fashion between all individuals and their individual judgments and us. And the general hypothesis is that humans have a much better idea than machines over what other humans will find interesting. Machines could try to get assessment of quality by looking at the ratio of word lengths and flash content and graphic sizes and graphical elements as relative to words and so forth. And they might be able to guess at a crude level whether you will find something desirable or not. But they're not going to be able to find, to really have a sense of what humans find aesthetically pleasing. And an extreme view of this, of course, is the use of collaborative filtering in terms of assessment of restaurant reviews or movies or a number of other things, which I'll discuss in a second, where it's very hard for a machine to have really any sense about whether a restaurant will be good or not, just by looking at the menu. I mean, there may be some characteristics of certain, throwing in of French terms and exotic spices that might somehow correlate with high quality, it also might correlate with pretension. It's hard to really know whether this is a good fit for actual quality of product. Likewise, can a machine read a script and assess whether or not a human will like this or not? Again, very difficult. Can a machine look at a movie and assess based on strictly mechanically accessible properties whether a human will actually like that film and whether it's worthy of an award? Again, it's a desirable outcome, and there are a lot of interesting research to be done on that very question. But the hypothesis is that humans will always be able to trump machines in assessing what humans will like, whether they will consider it relevant or not, whether they will consider it appropriate for a given response. So the general idea here is that we have a matrix here of users and judgments. Users and web pages or content. It doesn't really matter if this is a page or not. This is a document ID. This could be a movie, it could be a restaurant menu, it could be an image, it could be a web page. It doesn't really matter. So we have users and content. And for each of these pairings, we have a ranking. And this could be on a 1 to 10 scale or a 0 to 1 scale, irrelevant. The point is we're trying to collect these things. Now, the general notion is, in the naive world, where we assume that all people have equal relevance, we can assess the merit of content number 2, or web page number 2, by simply taking the unweighted average of all users that have provided judgment. Now, you see this sometimes in Rotten Tomatoes, the website that does film reviews. You basically, or I think there's one where they try to take, so Rotten Tomatoes takes everything and maps it to a 0, essentially a Boolean fresh or rotten. There's another site that tries to map everything on a 10-point scale, so if someone gives 3 stars, very much like I showed in collaborative meta crawling, their 3 stars get mapped to an 8.2 based on some sort of algorithm of past record. It doesn't really matter how you get this. Lots of sites have multiple judgments, and we can essentially take them as an unweighted average. And that's assuming that all people have equal needs. The better way to do that is to say, aha, I like Rotten Tomatoes, or whatever this site is that collects judgments, but I tend to agree with these reviewers, and I tend to passionately disagree with these reviewers. They don't quite share my judgments. So I want to weight the reviewers more heavily that I tend to agree with, or that seem to have a better fit to me. This is probably more likely in terms of music reviews. While people may have very different judgments in terms of what constitutes good music, based on their own preferences and experience, and I don't want to weight people that share my general aesthetic taste towards music more heavily than I would weight those that are very different. Even though on an academic basis, one has as much right to give a particular country piece a high score than I do. Maybe it's technically brilliant. I just don't happen to like country music, and I don't necessarily want to trust their judgments, even though this may be a Grammy Award-winning, extremely high-quality piece of composition. It just does not match my needs. So the question then becomes, how do we weight these users appropriate to their relevance to me? And it's not only their relevance to me, it's their reliability. Someone might have very similar needs and interests and preferences to mine, but their way of capturing these judgments has been very flaky. Maybe it's done through automatic means, through an eye tracker or through a page ranker, looking at how they scroll or whether they print it or not. And that's a very coarse judgment. So I might prefer something who's not only relevant to me in terms of shared interests, but also has reliable, robust judgments. Again, really doesn't matter. We're left with this matrix, and we'd like to know how to weight these things. So one model is simply to weight these judgments based on the similarity between you and me. Okay, so this can be either some sort of cosine similarity of the vectors, as we'll see in a second, or it could be a literal probability of the probability of relevance to me given the relevance to you. It doesn't really matter for this particular thing as long as it's somehow a weighted assessment of the fit between you and me. And then I can use that weighting to essentially do a weighted combination of the relevance judgments of the individual. So the probability of a page being relevant to you given its content, i.e. your judgments. So in this particular case, what we'd like to do is weight each of these scores for content 2 based on the similarity between user A and me, similarity between user B and me, and so forth. Now, how do we get that similarity? Well, from Jim's presentation this morning, a trivial option would be to take user A's judgments, user B's judgments, and measure some sort of similarity metric, either a cosine similarity, where you take the inner product of 3 times 1 and 4 times 1 and so forth, and normalize, or some sort of a divergence measure. It doesn't really matter. We'd essentially like to come up with a particular pairwise assessment of the similarity between the judgments of any two individuals, or any individual and me in this case, and then use that judgment to weight their judgments. Straightforward. Yes, sir.
So if I've already ranked on documents for Alzheimer's, then there's no real need to use any other information, right? So this is for the case where I'm trying to develop based on a past set of queries.
Okay.
My similarity to a number of users.
Well, okay. First, let me explain this in the easier context, where we have a space of things like movies or restaurants or recipes, where in general it's a standing kind of information need. What is a good film? And in that particular situation, go away, please. No. I don't want to run out of stretch my battery. Thank you. In that particular situation, the assumption is that if someone shares my judgment in food or music or movies, today they will share it 6 months from now and a year from now. So in that particular situation, we believe that all of the content is relevant in terms of making the pairwise similarity between A and B. Because it will persist, and it's equally relevant in terms of assessing that content. Now, you make a very good point that for a given query about Alzheimer's, obviously that's not going to be, so we could indeed collect this universally for a given query. But we also make the assumption that if someone, given a query Alzheimer's, will share similar judgments about what's a good response, they might also share similar judgments about what's a good response to Lyme disease or lupus or any other illness or other things. I mean, presumably there's a general class of judgments that children in school have certain needs, which are distinct from specialists and caregivers and assistants. So you're very correct that we somehow wanted to divide the query space into a set of particularly relevant judgments by which we can fuse these things productively. It's not necessarily the case that if two people share similar judgments about what makes a good response to Alzheimer's, they will share the same response as to what makes a good response to Britney Spears. Someone might be interested in the news about her, someone might be interested in her music. Or someone might be interested in the fan side. Again, age is probably a good predictor, and that young kids probably have different needs from older people. But among professionals, it's not at all clear necessarily what that breakdown will be. But excellent point. And one of the things, of course, is that we can take this matrix and run singular value composition and do some sort of dimensionality reduction, such as we can actually get, hopefully some of these things emerging as latent clusters, latent properties that will handle both sort of the group similarities between that underlie the dimensions that underlie young versus old and professional versus not, and some of the similar properties of the queries of the content as well. Okay. Hopefully that will all emerge through dimensionality reduction. So again, one is just to do this sort of raw weighted similarity. Another is to have an explicit sort of latent variable of the group that we can either model directly through self-identified membership, or we can learn through some sort of latent modeling. But in general, we can make this a little bit more straightforward by detecting the probability of relevance to a group of a page's content, and then a probability of similarity between me and that group. And again, we're not using a single fixed group. This is not a strictly Boolean membership. This could be a weighted membership where we have these sort of underlying dimensions of background, and we would like to essentially find, okay, I'm a little bit, like a high schooler in terms of my music taste, but I have other tastes along these dimensions, and sort of try to sort of profile me as a mixture of different group properties. Now, there's two more meta comments on this. This has been used, there's a whole literature on collaborative filtering and recommender systems. And it's been used very productively in things that you wouldn't even think would be possible. Obviously you can imagine sort of text-based things, but when we go into images, these things are actually very good at predicting your desire for artwork, what you aesthetically find pleasing. Because if you say, I really like these things and I don't like these things, it can basically learn that there's some property about the particular artist or the period that you learn, which is obviously learnable by machine as well. If you have a set of judgments about individuals, a machine could learn that I like Monet and I'm not fond of O'Keeffe or something, and that would be something. And that might also extend to the period where I'm not a Titian person, but I am, like Renoir. That would be something that it could learn as a machine, but a human could never learn that I necessarily prefer paintings with certain kinds of aggressive brushstrokes or whatever. Maybe it might learn color through image analysis, but there's certain kinds of aesthetic qualities. It might also learn topic. Again, I'm trying to compare here machines versus humans in terms of what's learnable. A lot of the things that would go into this matrix could be inferred through supervised learning by machines for humans. But what's not going to happen is that they will be able to assess these meta things. Now, paintings are somewhat different in the sense that you often have sort of common trends, and once it's been identified that I like Impressionism, that will increase the probability that I like other kinds of Impressionism. But what about photographs? If you basically take photographs of people or photographs of travel scenes or just general compositions, the best of the web. People go through and vote on msnbc.com for there's 15 pictures, and you pick your first choice, and that gets reviews. But these things could also be collected, and you'll try to say, okay, as a machine, could I predict which of these pictures person A will choose next week, given this choice? And clearly, the overall average, the collective wisdom of undifferentiated crowds, that i.e. the first choice winner, is a good predictor. But if I could also predict that I like quirky things, or I like cute little animals, or I like dramatic weather, or these things, machines can only go so far. There's some je ne sais quoi about relevance, about aesthetic properties that two humans could predict much better than a machine ever could. So, and then this has been even productively applied to humans' aesthetic responses to physical attractiveness. There's, I think, a site called Am I Hot or Not, where people put their images up, and then this is a true masochist, because they're essentially looking for rankings of others about how attractive they are. And people are often quite brutally honest in this respect. But you also get relevance judgments that are in some cases quite accurate about how different individuals aesthetically respond to images of people. And I'm sure dating services collect these things. Now, we could model that to essentially say, okay, trying to predict on a purely mechanical level whether human Y will find person X attractive based on age or hair color or height or weight or other such properties, or the symmetry of the features. Maybe we can measure the eye distance or things, and we discover that you tend to like people that have narrow eyes as opposed to far apart eyes and so forth. You could do that. But in general, that's always going to fail relative to the judgments that a given human will be able to say, I think you will find this person attractive. And that will always, in general, be second in terms of response quality to undifferentiated collections of things, i.e., I personally find this attractive. You and I tend to share the same generic judgments based on past histories. So my sort of gut intuition about attractiveness, weighted over past records, might be a good indicator. And if we have lots of me or lots of you, you'll have a much, much better collective judgment about whether a person will find someone attractive. When you can never really assess that based on objective criteria. There's not a single set of features or parameters or properties in terms of all biometric characteristics that a human could ever say, you will like this person as opposed, sorry, a machine could ever say, you will like this person as opposed to X. Now, it would be interesting, of course, to do a bake-off where we essentially try to have an individual expert versus my best friend versus a machine versus the collective wisdom of all the participants in Am I Hot or Not, trying to predict whether I'm going to find person X attractive or not. That would be an interesting bake-off. The same thing could be done for trying to predict whether I would like recipe X. Obviously, I could learn that I don't like nuts and shellfish. I'm allergic to them. They make me violently ill. But I also like certain spices. I'm very fond of cilantro, and I'm not really fond of curries. You can learn that by making an assessment of my judgment towards recipes. You could also ask my friends and my wife what I like. Or you could take the collective wisdom of people who tend to score recipes similar to me. I hypothesize that the latter will tend to do best, as it would in film ranking, as it would in human rankings of images of people, as it would in ranking music and so forth. There's just something about this inexplicable assessments that individuals tend to give that don't necessarily correlate with purely objective measures. Now, we may get to that point where the machine can outperform, or at least perform as well as a human. But in general, human computation about what humans like is going to be much better suited to the task than silicon computation. Okay. So it's interesting. It's well worth doing. I encourage its pursuit. Okay. Any other questions about this before we go on to further topics? Okay. So let's quickly skip over to characteristics of sort of link analysis here, and I'm going to zoom through a lot of this here. In general, we can view the web as a directed graph. So we have multiple pages, and we have anchor text and hyperlinks. And can we use this graph structure to somehow assess relevance? Now, obviously, in the early days of Google, this was the pathway to fame and fortune, but does it have relevance today for our tasks? And the answer very much is yes. And this particular model of link analysis, of graph analysis, very much persists as a relevant task for a lot of what we care about. And we make a couple of assumptions here. The first is that hyperlinks are indicative of a relevance, that if I link to something, that is an indication that I think this is meritorious. There's an assumption that the description that I put around a particular document link has some relevance to what I actually believe is contained in that. I know that Ani, in her presentation on summarization, made this point explicit, that one of the good indicators of the content of page B might be how I describe it when I link to it. Because sometimes I'm trying to encourage you to either take that link or use the link to motivate a sentence or whatever. But in general, what's surrounding or inside that link is in some ways a pithy summary of what I consider to be relevant about page B. And finally, there's this notion that these links and assessments and summaries should be weighted by the inherent merit and authority that we believe that page A has. So a highly meritorious, a highly authoritative, authority in the sense of respected as opposed to dictatorial, that kind of authority would be a useful parameter in terms of weighting these judgments. Again, think of this very much like what I just said with respect to collaborative filtering. We're essentially taking the judgments of others and averaging them. In collaborative filtering, they were explicit judgments. They were scores on a 10-point scale, or they were scores derived from my click history or my scrolling history. In this case, they're scores assessed through another hidden means, which is the use of links. The inclusion of a link is an indirect way of saying I give this 5 stars. Now, again, it's fairly crude in the sense that in a given page of links, there's no notion of really highly recommended versus not. Now, there might be. Any suggestion of how we might do that? Maybe the things on the top of the list might be more meritorious than later down. Again, they could be alphabetical, but there is perhaps something, they also might be chronological, but it may be the case, in some cases, things higher up may be a better indication of quality. There might be certain regions of the document where links have a higher status than if they're buried in a footnote or whatever. Again, we're trying to intuit something beyond just Boolean relevance. So in some ways, it's impoverished with respect to what we saw for collaborative filtering. We don't have really much more than just this is or is not considered relevant by the fact I linked to it. But the nice thing about this is we have this in vast quantities. Unlike relevance judgments, which are very hard to capture and are hard to share, these things are around in vast quantities for the collection on the web. Now, that does not make them necessarily desirable if they're not good, but we actually find that they're actually quite effective. Now, I would like to make one meta comment. Actually, I'll come back to this. So we'd like to come up with a weighted link of these, a weighted average of these links as an indication of votes in favor of page B. Okay, so that's our meta goal here. Now, just to sort of echo what Ani said in terms of the content, the descriptions that go into this links can be very useful in terms of the surrounding text, other siblings, paraphrases, and there's much that can be learned from anchor text. And I'll leave Ani's lecture to speak to that. Citation analysis, again, there's a very long history that well predates computers in some sense on this topic. The general notion is that citation is an indication of perceived relevance, and co-citation is an indication of similarity. If I tend to cite the same things that you cite, that's an indication that we tend to think alike, we have similar interests, we have similar properties of what we consider good. And if you cite something that I've never seen before, I've never cited before, that's probably an indication that I should look at this article, just because we have similarity on that basis. So we can use co-citation frequency to essentially assess, very much in the collaborative filtering spectrum, whether two individual reviewers or assessors should be weighted heavily in terms of weighting citations and links for relevance. Now, we'd like to go beyond that in the sense that individual sort of query-specific orderings are problematic. Judgments on any given sort of subscale are really not doable on a web scale task. So what we would like to do is have some sort of universal ranking of goodness that we can. This is sort of similar to what I was saying in terms of overall quality. So is there a sort of a universal ranking of web pages that we can say, independent of a particular query and relevance, that this is a really high quality, respected document, respected web page. This is a very low quality, low respected web page, or low production values. Just in general, something that would not tend to be desirable as a link response. And come up with a sort of universal total ordering of all of the pages on the web. And then take the intersection between that total ordering and the actual content scores, i.e. the match between query terms using TF-IDF or other such means, as Jim talked about this morning, and come up with a consensus that both is relevant to the topical content and also relevant to the sort of universal production values ordering. So, and the response, of course, is the famous PageRank, where we have all sort of pages in the web with some sort of universal merit score, and we find those documents that match the terms, and then we return the literal matches in response relevant to, sorted by this universal PageRank score, weighted in various ways to a classic TF-IDF sort of score of the fit of that page. Although we don't typically need to do that in the sense that once we get above a certain threshold of this page is obviously relevant, there's so many mentions of the term we're looking for that we really are now just needing to sort between an obviously relevant space. So coming up with the PageRank clearly has merit. So how do we do that? How do we actually come up with this total ordering? So as I noted before, we have at our disposal these links. They're proxies for votes of quality. They're not weighted. They're Boolean. But we can use them as our basic model here in terms of graph analysis. Now, we could have an undirected graph or directed popularity. We'll discuss the merit of those in a second. And in general, we would like to use these. Now, of course, this is very much amenable to spanning. So clearly, if I want my page to be considered desirable and have a high score on the PageRank algorithm, I can just create a bunch of proxies that will all link to it, and that will give the impression that I'm popular. Unfortunately, we'd like to overcome this by recognizing that all or not all individual votes are equal, that my proxies probably have no independent authority, especially if that authority is not shared by other sites, while other sites may have judgments that are highly correlated with authoritative respected sites, or even better, the linker might be a high-quality respected site like the New York Times. So we have this sort of general notion that linkers have inherent authority and respect of their views. So we'd like to come up with that particular assessment as well. So what we'd like to do is come up with an algorithm that does both of those things, both sums and weights the inbound and outbound links, and come up with the appropriate weighting that's reflective of the merit and respect that I should assign to any given judge. And the PageRank algorithm is effective at that. It's basically a random walk. We essentially have a given page that we're at, and we have 3 outbound links. We have a probability of 0.33 of walking to any one of those things. And we essentially just model the graph traversal that happens. And in a steady state, each page has a long-term visit rate, essentially. And this long-term visit rate, if you take this as an overall graph analysis, is essentially the page score, their overall score that we would assign to that page in terms of merit. Now, unfortunately, this has, in the naive sense, various problems. One is that there are obviously dead ends. Some pages have no outbound links. So lots of people might link to them, but there's no outbound links. So we often have, it's difficult to talk about long-term visit rates in this context. We also have situations where there's cycles, and then people sort of link to themselves or link to a friend who links back to them. And this is problematic as well. We also have the fact that the graph is not fully connected. Not all areas of this link space can be accessed through a single and individual source page. There are islands that are just simply not connected to the overall rest of the web link structure. So there are a couple of different approaches to responding to this. One is at a dead end, we can teleport. We can essentially randomly jump to a given web page, which helps make the random walk algorithm effective. And there's a certain probability of making that happen. That's a parameter that we use in the algorithm. Now we cannot get stuck locally, and let's look briefly at how we compute the visit rate. Now we can improve upon this in terms of better modeling of where to teleport, but I'll come back to that in a second. So in general, we have this Markov chain with n states and a transition probability matrix P. And I actually am going to skip through this relatively quickly in the sense that there's probably 30 slides here, and I have 5 minutes to cover this content. So in general, we're in a situation where, actually, let me quickly skip to something that might give you a better intuitive feel of how this random walk works, and then I'll come back to the content here. So you can think of it as follows. You have these outbound links. If I have this initial merit points of, let's say, 100. Again, we'll describe where these merit points would come from. And if I have 2 outbound links with equiprobability, I would assign my 50 points randomly to each of these sites. So I have, these would both get my 50 points. If site B here has 9 inherent merit points to spend, it would give 3 to each. This site would have 53. Which it could then spend on its outgoing links. Okay, so we can clearly imagine how this would work in any given situation. And in a steady state at convergence, the long-term visit rate actually corresponds to the total number of merit points that we have. And as you can see, this is clearly in a stable configuration. A has got 0.4 merit points, which it spends on 2 sites, both 0.2. B passes all of its merit points on to C. C has 0.2 from A and B, and all of which gets passed on to A, which is the only source of its merit. So clearly we have sort of long-term visit rates of 0.4, 0.2, and 0.2 that correspond to these things. And it clearly has converged in this particular graph situation. Now, the question, and you can sort of think of this as sort of pouring water into tubes and basins where the tubes have various parameters and a number of outgoing things. But in general, if we sort of pour water into this space, the levels at which it sort of stabilizes is proportional to the sort of long-term visit rate, where merit is sort of proportional to water. Now, initially, not all sites were given equal merit. In particular, there was this notion of sort of inherent authority that was perceived. So sites like the New York Times or respected universities, those initial links were given higher sort of inherent merit, partly to compensate for the problems that we would have where people would have like a gambling site and they would have all their friends linked to it, and you would have this sort of localized network of sort of self-linkage that would not have any intrinsic merit bestowed upon it. Now, Google did try to get beyond being editors. They didn't want to essentially be judges like Yahoo was at the time in terms of what is good or bad. They wanted to have this as truly voting by crowds and not gameable. But for various reasons, there was advantage to having sort of initial configurations of merit assigned based on sort of more inherent abstract concepts of prior merit for given authorities. In terms of the link cycle problem, this is problematic in the sense that we have, if I have a cycle, essentially we can potentially have impression of infinite merit accumulation through a cycle. Now, we have to have some mechanism for dampening that, either through this random teleportation model that I just described, or at this sort of loss means. So let's go back to that. Okay. So in general, as I said before, this random surfer modeler has a number of problems in the sense that teleportation, although helps overcoming some of this infinite cycle problem and the problem of losing entire non-connected regions of the space, it's also not realistic in terms of how people actually behave. In general, I'm not going to randomly jump to a page. I'm going to typically jump to a page that's somehow related to or relevant to what I'm actually viewing. So we would like to have our teleportations or our jumps in this algorithm to be based more on topical similarities, such as like a bookmark or, a topical relatedness, i.e. something that's inspired by the same thing, or a sort of inherent sort of prior, things I might bookmark or a stable thing. So if I'm generally browsing the web, I might periodically jump to CNN to make sure that we've not been bombed or that such things, or the stock market hasn't crashed. Just as a sort of random prior of visit that I would typically do in a given day. And we can model that as part of our random walk model of certain sites that tend to just get visited inherently, independent of any given query. So we can set up this sort of random walk model to have teleportation that's sort of conditional on the individual similarity of the query of the page that I'm at. So if I'm on a sports page, I will typically jump to another sports page, and also have this sort of prior notion of sites that get visited generically. Again, I'm going to skip through this. There's a general notion. I mean, I'll put my slides online, but you can essentially read through this notion of how we can infer hubs and authorities from the page rank algorithm. Generally, these things tend to converge relatively quickly. It's been observed in a relatively small number of iterations, gives you close to stability. The problem, of course, is these graphs are enormous, and fitting them into memory is problematic. So again, there's significant problems here. There's a proof of convergence in the slides if you'd like to address this. So I have officially 6 minutes left. I do want to cover, I guess, one more topic. No, that's not the one. Shoot. I do not want to buy you now. Decline. Thank you. 20. Yes, sir. Okay. So again, I'm going to skip through this quite quickly. We have this notion of sort of web agents of various degrees of sophistication. I'm not going to sort of go into this beyond. The fact that we would like to be addressing sort of robots and agents on the higher level of intelligence. Those that not just do directed search and distill information and summarize information and look for bargains, but those that actually become our avatars, those that engage in active of web buying as buyers and sellers, that involve in true bartering or dialogue between parties, and are imbued with the authority to reach agreement and act on those things. And to do that, to have these things to be our true agents and our true personal shoppers, shall we say, who have the full authority to act on our behalf, they have to be imbued with a certain amount of both trust and respect that comes from truly understanding where we come from. So sort of going back to this notion of modeling the individual, we would like to have agents that are able to sort of model our own behavior and learn about what we do well, how we act. And this might be in terms of calendar scheduling, in terms of constraint satisfaction about how I would organize my day. It might be in terms of what I would buy, sort of viewing eBay auctions or viewing Amazon.com specials, and basically saying, okay, I'm going to recommend this particular purchase because based on what this person's bought in the past, using collaborative filtering kinds of styles, I would assess that this person is likely to want to buy this thing. And the next step in that, of course, is saying, okay, I'm going to give you the authority to buy this. You would have essentially a situation where you'd have my web shopper out there saying, oh, look what I saw on eBay. The auction was about to close. I went out and bought it for you. I'm sure you'll like it. Or this was on sale on Amazon, limited time. I just got this for you. And you'd have your personal shopper just sort of ordering things that would arrive home at your doorstep by UPS. That would be a wonderful little world. And we can imagine a situation where these sort of shop bots would be doing this on our behalf. Now, I spent time in my course sort of building these things and showing people how to do it, but the best, most interesting thing about this task is trying to intuit whether humans would actually want to buy this item or not. And of course, having machines doing the comparative shopping, looking online, finding the bargains, comparing reliability of the sites, shipping costs, and everything else, is problematic for the individual sellers because they lose brand loyalty, they lose all the advertising they get. They don't want machines to be doing the shopping. And this is very much a tension between these things. But it's interesting to the extent that you can harness collaborative filtering and personal modeling, user profiling kinds of things to basically come up with a meta shopper that would find, okay, you're looking for X thing based on all the constraints I know. Here's what I recommend you buy. And once that trust is established, you actually would have a person doing it. Now, one of the problems, of course, with collecting all these relevant judgments, as I've been describing so far today, in terms of people's judgments about what's a good web page or what's a good restaurant or what's a good film, is that this is not cost-free. And I'll give you an example. Clearly, if collaboratively it was discovered that lots of people, generically, or lots of people like me in particular, will tend to like restaurant X, that has undesirable effects on me. And particularly if one of my judgments that this is a fantastic restaurant gets pooled into this collaborative wisdom, and that negative effect is lots of people people go to that restaurant. It becomes very crowded, and my ability to exercise and use something that I like, if it's a resource-constrained situation, becomes limited. I can no longer, the fact that I've shared this tip, this is a great restaurant, becomes part of the public good, and then that either limits my ability or in some cases actually changes the quality because it becomes too crowded and becomes less desirable. Now, some things like movies, maybe there are crowds in the first weekend, but you can print more copies of the film. Individuals, I don't necessarily want to advertise about the attractiveness of a girlfriend or something because that will make that person more desirable. Likewise, with things that have limited, recipes can be replicated indefinitely. But another problematic example is in terms of business intelligence or like a company. If there's strong interest in a company or a lot of people were linking to a company or clicking on a company, that particular relevance judgment, you're talking about medical devices or a certain query, and there was a particular collective judgment that this company was a good response to that thing. That has value. People could exploit that to recognize that this is actually worth investing in. And for that reason, there's the link history, the scroll history of individual sites, especially in a corporate environment, are very much considered proprietary because it does reflect corporate interests, corporate judgments that assesses the affects the value that we would want to place on individual linked entities, and that value often translates into monetary value. So for all these reasons, there has to be some way to encourage people to spend their capital of knowledge, essentially, about what they like and what they don't like, for the collective good, without having them burned individually. And another way they can be burned, of course, is through privacy concerns. If I start buying diapers, I all of a sudden start getting lots and lots of ads for all sorts of child products because people know I have a young child, and other such things. It's quite disturbing, in fact, to see how your ad profile might change based on certain queries you might have issued or certain places you've clicked. Once people start modeling your interests, then that sort of pigeonholes you and becomes you don't necessarily want to model what's inside your head becoming part of either the public good or of individually accessible micro analysis of your particular interests and priorities. Companies, again, have this very much the case. They don't want people to know what their corporate interests are in advance. And finally, sort of who has the rights to this information, given that these things have financial value. So one response to this in terms of the privacy concerns, is to ensure that there's some trusted organization that really only does this in aggregate. And there are ways to hack that, but aggregation does provide some anonymity. And the other response, of course, in terms of having financial value, is you actually can be in a situation where you pay people, either directly or indirectly, for these judgments. Because if we assume that they have value, if we assume that my searching ability, my ability to find a good restaurant or a good movie or a good recipe or a good spouse is essentially influenced by the collective wisdom of others, I should be willing to pay for that wisdom, A, and B, I should be paid for sharing my judgments. So even though every single judgment I give may slightly hurt me in the sense that it might increase the desire of that restaurant, the crowdedness of that restaurant, if I collectively get money for that judgment, that compensates the additional crowds that will be seen there. So how can we monetize this? How can we actually encourage people to sort of get paid for this? So in the last few slides, I'll address that tension. So when I first started teaching this class, over, I guess 14 years ago, I came up with this sort of vision of the future structure of the web. And this was really much like a sort of corporate economy where you had this initial sort of level of content where we would then have finders, which were sort of scouts and spotters, that their job was to find new content rapidly. They would scour for sites looking for things of relevance. They would be compensated for how fast they found it. So if this was a 10K report for a company or some sort of financial news, they would try to acquire it and pass it on as quickly as possible, because given the timeliness of information is relevant. And instead of having thousands of sites constantly polling for new content, you would have these finders that would get tips and sort of detect new information. Then you have these gatherers that's job would be to sort of distill, analyze, synthesize content, to come up with an essence of what was in a page. Essentially a summarizer. They would pull out information in terms of fielded data to be searchable by database. They would essentially structure things and distill. You then have these brokers. The primary job would be to sort of search or index content. Now this is partly based on the Harvest architecture at the University of Colorado that came out in '94. Some of these terms are theirs. But in general, these sort of brokers would be based on sort of the retail selling of what the wholesale gatherers would provide. So they would be the indexing companies, the search companies that would leverage the content that these gatherers would provide. Then you have these meta brokers, sort of meta search, meta crawlers that would attempt to synthesize information from multiple brokers. And then you'd have these user agents that would essentially borrow information from various levels of the hierarchy for goal-directed, personalized search, extraction, and even dialogue. Now, of course, individual humans could extract and interact with each of these individual layers as appropriate. And what made this whole thing work is this notion of money. You'd have people would be, I would pay meta brokers to come up with information I need at very high quality in a timely way. Now, certainly you can imagine this in a corporate space where you're interested in actionable intelligence, shall we say, with respect to financial news. And I'm willing to pay for that through high quality meta financial sites that would pay brokers of financial information, which would pay gatherers of that information to do high quality distillation, to just detect corporate succession or acquisition or whatever in a high quality information distillation and extraction. Those would in turn pay finders to come up with this in a timely way, such that they would be the first to discover that an acquisition took place. And all that would get passed up through the food chain to give me first knowledge of that acquisition, such that my user agent could then do a stock trade based on my directives or perception of my directives to make money for me. And there has to be some sort of monetary value here in the sense that I would have to pay or be able to pay for these services in terms of timely response or quality of response in a way that incentivized these sites to do it. Now, unfortunately, there's two problems with this world today. One problem, of course, is that people are not willing to pay. This is pretty much an ad-based economy, and with few exceptions, such as financial services industries, where people really are willing to pay for timely information in a fast way. Pretty much all of this economy works entirely based on nominally free interaction with ads is the currency of the day. And I believe that if there's some way for people to do this on a subscription service to pay for higher quality results, then you might see more of a retail economy emerging here. The other problem, of course, is this has become a monopoly. All these layers are today run to some extent very, very well, mind you, by one particular company. And that's good in the sense that all these things are being done. Google and Yahoo and Microsoft do put a lot of energy into making sure they have scouts that find information quickly and in a timely way, distillers that pull out facts, and high quality sort of search projects. But this is all being done in-house through vertical integration as opposed to having customization. Now, you are seeing some customization emerge as different companies become specialists in images or video or financial news or sports news or whatever. And sometimes they're being bought up by the big companies, but in many cases, there are some specialized sites that will get sort of brokered together. There may be interest in sort of a richer, non-monopolistic economy here. Now, in general, there's this notion that there's already sort of too much there for even a single company, a single source to do extract, understand all the knowledge out there. So I envision some more specialization by content or subject or object type or language or geographical location, much like Baidu in China. Can much better understand the Chinese space than a US company potentially could. And in general, hope that we would see a true sort of wholesale retail information economy emerge. There are, of course, problems in terms of who profits. So my last slide here is essentially a contrast between two potential views of the world, bringing into what I've discussed already. One view is this web agent view, which is essentially this notion of we have automated models of personal preference interaction. So these machines watch what we do, and they try to figure out what I want to buy, what I want to see, who I want to date, where I want to eat. And this basically model me in every respect. They'll say, okay, based on what I know of you, you'll probably want to read the next 3 news stories. You'll want to see this YouTube clip. You want to see these 3 cute pictures. You want to have this for lunch today. You want to buy these things on eBay. It was essentially trying to model through observation and through machine learning exactly what kinds of things I would want to do, how I would want to behave, and essentially act on my behalf. I would just become this future blob sitting in a chair, and my avatars would act and do everything for me and essentially just feed me information based on past preference. And the sort of slogan of that view of the world is who needs humans? I'll have my web page talk to you, but your web page in the morning. We'll schedule things. We'll buy things for you. Things will just arrive on your doorstep, and you won't need to think. Your past preferences and your past behavior will be modeled by machines, and we'll just learn you, and we'll have your own personal shopper and personal avatars act on your behalf. And the contrary judgment to that is one of a wisdom where machines can never really know humans as well as other humans can. No matter how good machine learning becomes, no matter how good the feature space becomes, it's not really viable for a machine to really understand my true preferences, my true aesthetic judgments, my true tastes. So let the humans of the world unite. Let's collaboratively collect assessments of individual carbon-based life such that rather than having a machine try to predict all these things, I would essentially take a weighted vote of my friends in a global scale, a massively global scale in terms of friends' judgments assessed on micro weighting over friends of friends of friends of friends, and people I've never even met before. We just happen to share the same judgments. And although, ironically, this is probably one of the best ways to better model humans and actually come up with truly relevant assessments, much more so than a machine could ever actually hope to accomplish, it's also, ironically, one of the most serious threats to privacy, in the sense that once you've sort of published your tastes on all dimensions for the world to see, that becomes a model of what's inside your head that could be exploited financially and on all different levels. So in general, there's a tension here. Do we trust machines to model us, or do we trust humans to model us? And if we do the latter, then we have to be willing to share our judgments. And that has costs in terms of crowded restaurants and in terms of increasing the price of companies that we hope to acquire. And again, I think it all comes down to money. Are we able to compensate people for this? Are we able to essentially pay people for the judgments to compensate them for the losses that they will achieve, either through micro-billing or cyber cash or some sort of way of compensating and paying for this model? Because people are not willing to do this purely out of egalitarian sort of collaborative good for all. There's too much effort that goes into that, and we would like to be able to have some sort of compensation to make this possible. Now, I suspect that the overall future of the world is some combination of these things. We would have compensated people who, depending upon their needs, would be willing to spend more or less time giving their judgments. And of course, some people who need money might be willing to give judgments in abundance. The problem, of course, is that those people may not necessarily be similar to me. And it's people who have no time who need those judgments the most. And the question is, how do we compensate people who are similar to the people who are very, very busy and wealthy, such that their judgments can be acquired? And of course, this is all an economic question. What is the appropriate way of incentivizing and compensating people? And of course, the same thing works in the corporate world. I mean, how do we compensate sort of high-value professional judgment about what makes a good company or what makes a good acquisition? Has enormous value, and you want to pay people more for higher quality informed judgments than naive judgments. So this is not just equal compensation for all. This is very much compensation based on quality and relevance, which of course ties back into the whole graph analysis view of the world, where we want to essentially compensate the authorities more for their judgments. And it would be interesting to look at the graph model where instead of having all costs being equal and all scores being, all links being equal, we have costs associated with these sites where you don't have access to all these things. And not all outbound links are equal. They're based on graded assessments. And if you redo PageRank consistent with both variable cost and variable scoring, you get a very different world. One that's essentially reflective of a true economy, that would be reflective of a true environment that you would actually have in what makes capitalism work. So again, this is a notion of information capitalism in the future. We'll see whether it emerges or not. It'll be interesting to see 20 years from now which of these two views indeed wins out. But I suspect it'll be a very different world than we see today. Okay, sorry for running over. Any questions, or should we go to lunch? Okay, lunch is good. Thank you.